Hello everyone, so we are back again with our pending classes on NEET 2021 Physics and myself Rahul from Minerva Adventure on the behalf of mocktest4you, and we are going to start again from where we left from dimensional analysis. We have successfully finished up the dimensional analysis and we are going to start the error analysis or theory of errors. And we know very well, in any physical experiment, if we want it or not, still we have sufficient amount of errors which makes one experiment little bit of controversial, because there are some errors. If we are so much willing about it, still we can't vanish it completely. We can minimize the errors, we can reduce the errors, but we cannot make the error zero from any experiment. If we desire it or not, error has to be there, and error is going to stay in the experiment, and there must be error for any kind of physical or practical experiments. Now the thing is that whenever we think about any physical experiment, we need to think about our error, how much error we are getting, how less it can turn to be, or how can we calculate the percentage error in the whole calculation. First of all, if we look through the error, so if the error is big, error percentage is big, the work, the experiment, the event will be less accurate. Suppose you are sitting for an examination, and in that examination, suppose you are getting 100% marks, and when you are getting 100%, like in board exam, you have got 100% in maths. So in maths exam, if you take it as an experiment, so your error is 0% over there. In chemistry, suppose in the board percentage you got 93. So that is a 93% is your obtained marks. So 7% is your error. Like in physics, suppose you have got 94. So 6% is your error. In biology, you got 98. So that is your error is there at 2%. So this is the way, this is the approach of considering error. That whenever we do perform some experiment, there must be some error. And we can't actually vanish it. We can hardly minimize it. And error minimization is a big technique. And whenever we follow it, we need to remember that error can be minimized, but error cannot be vanished completely. So for everywhere, every kind of experiment, we should be that much focused that whenever we think about error analysis and error theory of errors, there must be something like techniques and patterns through which we can minimize the errors. Like you can see what kind of error we are going to face in any physical experiment. There are different kinds of error we can face. First of all, we can face something called which is personalized error by some observer who is doing the experiment. Suppose he is not maintaining the parallax. That parallax error can be there of the perpendicular viewing. Suppose he or she, the observer, needs to switch on the stopwatch. But during the switching on the stopwatch, little bit time lag was there. So 1 or 2 seconds or fraction of seconds got extended for the experiment. So that is a kind of error. Suppose there are different types of measurement of using scales and tapes and like that. So there are some kind of personal errors. There can be instrumental errors, that one particular scale is broken at one spot. So that part is not giving you the proper data. Suppose there can be periodic error, some one machine like centrifuge or something, it is revolving, and when it is revolving at one position it is broken or there is a notch, and when after a particular period, after a particular time period, the error is getting repeated. So these kind of things, periodic errors are there. And apart from all these, there are random, periodic and progressive errors. And if we collect them all together, it will be formed called as gross errors. So what kind of error we actually get regarding the physical experiment, that is actually gross errors. And this gross error is what we measure actually, that is a gross error. And suppose the quantity is x. and this is the value we need to have. So this is called the desired value. So this is what called the desired value. But in place of x, what we get during the experiment or after the experiment, what we get? Suppose we get a value which is either greater than x or less than x. So let that value is ultimately like this, x plus minus delta x. So this x plus minus delta x, so this is the value actually. So it can be either greater than x or it can be less than x. So whenever it is either greater than or less than x, we are pretending. So one thing we should notice from here, this particular thing, that is the delta x, whether it is plus or minus. So this delta x is actually the error. This x is the desired value, and this x plus minus delta x, the total thing, is the obtained value. So the difference between the desired and obtained values, that is the plus minus delta x, and this is actually called error, which is very, very important for us. So this much amount of value which we don't want to have, which is our unwanted value, which is undesired, which we don't want to have for any reason. So this is called our error. So whatever the experimental result we have, there must be some errors that can be minimized. How? You know about Gregor Johann Mendel in bio, that he got a magnificent success in the field of biology and genetics. And why he got that much success? It was not because of his luck. It was not because of there was crossing over. It was not because of there was 7 opposite characteristics. There are all these things he can't decide. These all things are naturally decided, naturally selected for him. So he may think himself as lucky that the situation was favoring him. But here, we need not to forget, we must remember every time, apart from being a biologist, he was a greater statistician. Why? Because this particular theory of errors belongs to the field of statistics. And see what he told, that the sweet pea tree actually completes a multiple cycle in a complete year. So whenever we think about a single year time span, a sweet pea tree is completing more than 2-3 generations at a year. So that means within a year time, he is being able to run the experiment several times. So more the number of observation, more will be the success. So we know now there is an English proverb, practice makes a man perfect. Why? Because more will be the practice you are doing. So you are going to leading to the perfection because your accuracy is becoming greater. One cricketer or one footballer practices one particular shot to reach to the goal or to hit for the 6. So that is the practice, because if we do the practice means if the number of observation in the experiment is greater, then automatically error will be less and our work will be that much accurate. So this is highly important for us, that error can be minimized but cannot be vanished from the experiment. Now, when we think about gross error, what we can actually find out, that is very, very important for us. And when we think about the gross error, we need to know about one very important thing, that is, if we think about the term x, then x plus minus del x is the obtained value, x is the desired value. So here delta plus minus delta x is the error. Definitely this is the error. Now this delta x by x, which is very important, this delta x by x, this is called proportional. This is called proportional error, and This is called what? Percentage error. How can you get percentage error? Just multiply the proportional error into 100%. So that will be the percentage error. So finally what we are getting over here, in our syllabus we need what? We basically need to find out the percentage error, the proportional error, the gross error of the experiment. That's all, right? So these particular things we need to have, and little bit we need to have about our significant digits that we have done it in the previous class. Now from here we need to find out the error completely. First we need to focus on the systems of measurement, that whenever we do some measurement we need to concentrate on error, that whenever we do measure any quantity, that quantity is always having some sort of problem, like having errors or something like that. So when we measure something, let us concentrate. X is a quantity that I am going to have. Suppose you are measuring acceleration due to gravity. So during the measurement of acceleration due to gravity, that value you want to have, that for g, it should be 9.8 meter per second square. But during the measurement what you get? You are getting 9.8 plus minus 0.5 meter per second square. So this is actually your error. So you need to have your percentage error, you need to have your proportional error. That is hardly we want from this chapter. Now when we go for the measurement of error, that is called the error analysis. So we need to concentrate on some error equations. There are some dependence of some equation, like suppose W is a quantity which depends upon x, y and z. Let it be, it could have been more or less than this x, y, z, but W is depending upon x, y and z. How they are depending? Suppose it is depending like W equals to x plus y or minus y or plus z or minus z. So it is like this, x plus minus y plus minus z, like this. So this is the way of dependence of W on these three basic variables. Now if we think about the error of W, and there is no certain direct measurement way by which we can directly measure W. So how can you measure W? So obviously we can measure x, we can measure y and we can measure z, and if we can put the values of x and y and z in this particular equation, so definitely we can measure the value of W. So it's quite obvious that if there is no direct way, I have to go through some indirect processes. And what kind of indirect process is this? That if I can get the x, y and z, then definitely I am going for W. There is no rocket science behind it. Now the thing is that, so what kind of error I should get for W? That should be del W equals to del x plus del y plus del z, and always remember that error equations are always additive in nature. There cannot be any negative equation, negative sign, negative term in any terms for the error equation. All terms of the error equation has to be positive, and all the terms involving the error has to be additive one. So this is highly important for us. Now from this particular point, one thing we must notice, that is what? First of all, this del W we got. This del W is what? This is actually the error to find out or measure the quantity W. So if there was minus or whatever plus, the error equation will only carry the term positive. You should keep it remembered in your mind. It has to be registered always that error equation cannot be negative, it has to be positive every time. Now from here, one thing we are focusing, that this can be a type of the equation, but most of the times this error equation we don't need to follow. This is very simple. Not every time the equation will be linear. If the equation is in the product or quotient form, then what we will do, that is mostly important. Suppose x is a quantity and it depends upon some other basic variables like P, Q, R, S. So it depends upon some other variables of P, Q, R, S, and as you have already done from class 11-12 level about dimension, we have successfully recovered and successfully revised the concept of dimension in the previous 2 classes. So we know better that by dimensional rules, all the quantities which is actually controlling a single one, that means a single quantity is dependent upon 2-3 quantities, and they must be depending upon some parts of the dimension in the power. So the power is hardly important. So that is x is suppose related to this particular variables like some constant that is dimensionless constant. We know that k into p to the power a, q to the power b, r to the power c, and s to the power d. It could have been represented like this, that x equals to k into this. So this is the dependence between x and all these 4 variables p, q, r, s. Now let's come to the fact which is known as the error equation. That how can you get the error? We know very well that if the quantity is p, to measure p, what is the proportional error? That is del p by p. To measure q, the proportional error will be del q by q. To measure r, the proportional error will be del r by r. To measure s, the proportional error will be del s by s. So this is the situation. But suppose there is no particular way to find out the error of measuring x. So I have to find out all this and we have to put in a particular equation. So what to do for that basically? So I am taking that del x by x, which is very useful. The del x by x, here k will be playing no role here. It is a, the power is coming out, del p by p, plus b, del q by q, plus c, del r by r, plus d, it is delta s by s. So this is highly important for us, that this is the actual error equation we are looking for, and from this error equation what we can have, that if we can measure the errors of measuring p, q, r and s, so definitely this p, q, r and s, if I can measure successfully with the error, then automatically we can find out the actual value or the desired value along with the error. So it is the obtained value will have some error automatically. Now if we can take an overall percentage, so that is multiplied by 100%, so this should be nothing but the error equation. Just for an example, if it is given like x equals to a cube b square plus b square by root c into d. So if it is asked that what should be the error equation, see this is actually can be written as, you know, a cube b square c to the power minus half d to the power minus 1, you can easily write it. But if I think about the error equation, it can be written as, so it should have been written as, according to this rule, it should have been written as what? Here the constant is 1, so we need not to write. So it should be written as 3 del a by a plus 2 del b by b minus half del c by c minus, there is no need of writing that minus 1, minus del d by d. And we know very well what we have done before, that in error equation no terms will be minus, only positive terms to be taken. So these minus terms will be taken as positive. So always remember, in error equation, whatever be the situation of power, the terms should be taken as positive. The terms should be taken as positive. So this is very, very important thing for all of us that we need to remember. This is very, very important for all of us, that error terms has to be taken as positive. So this is very, very important. Again I am saying that from here the error equation, what we are actually having, we should remember this kind of form in our mind, and this is going to be the most important equation we have for our numericals. So let's go to the numericals, then only we will be able to understand the actual situation. If we think about this one, this particular situation, and if it is told in the question that for measuring A, the error is this much %, for measuring B, the error is this much %, for measuring C, the error is this much %, and for measuring D, the error is this %. So what will be the actual percentage error to find out the value of X? So from here we can write that del X by X % is actually how much? It's 3 delta A by A. So actually 3 delta A by A means the percentage of error in measuring A, that is 1 by 3%. So 3 into 1 by 3 plus, it is for B, that is half % delta B by B. So it is 2 into half plus, it is half into for C, it is 2%. And lastly it is 2%. So finally how much it is coming? So you can see that you can take the percentage out. So finally you are getting this, all these 2 3s are going up. So finally the answer is coming 5%. So this could have been a simple numerical, but this type of numerical have come several times in the previous competitive exams like NEET, BHU pre-medical, AFMC, AIMS, everywhere. So whenever we think about different exams, different process, but now one country is going for one exam, one country, one exam mode, and we are focusing for NEET, and NEET will carry this type of question for sure on every alternative year. Now error analysis is always an important chapter for the competitive exam, whatever be it's NEET, JEE or AIEEE or any state entrances. So when the exam, this medical entrances was state-based exam also at a time, once upon a time in India, in 4-5 years back, that time also we had several questions from this particular topic of error analysis. Now from here, we are going to discuss one after another problem based on error analysis. Suppose I am giving you a situation where X, like previously, X is depending on some other quantities like P square root Q by R cube S. It is like this. So suppose for P, the error, measuremental error is 1%. For Q, it is 4%. For R, it is 1%. For S, it is 2%. So what kind of error we are going to have? That is a big important question for X. So whenever we will form the error equation of X, it has to be like del X by X % is 2 del P by P plus half del Q by Q plus 3 del R by R plus del S by S %. So here if you go through the equation, given informations in the error, you can see the measurement error due to P, that is 1%. So if you put it here, it is 2 into 1 plus half into 4 plus 3 into 1 plus 2. So this much will be the percentage. So how much it is coming? Actually it's 2 plus 2, 4 plus 3, 7. So finally you are getting an overall error of percentage 9. So it will get a 9% error, and whenever we have a 9% error in any practical situation, so we will be going for this kind of error analysis where you can have a 9% error in the particular situation from this experiment, and this 9% can be any terms when the individual errors regarding the P, Q and R and S will have to be different in different occasions. So this kind of problems are always important, and moving towards we are moving towards the next type of problem regarding on error, and that will be a direct 1 degree measurement of, suppose you are measuring the radius of a sphere or the length of a cube or the radius or height of a cylinder, and you can have the volume measurement, surface area measurement of that particular thing. So we are going to that kind of problem for this particular session. So suppose it is given in a question that radius of a sphere is having a error in measurement that is 1%. So what should be its volume and surface area measurement error? So if I tell that error in radius measurement is 1%, so this is given. So I have to find out the surface area measurement error and I have to find out the volume measurement error. So what I can do actually here is surface area is 4 pi r square, volume equals to 4/3 pi r cube. So when we are doing it is s, actually both are function, both actually they are function of r. So if radius is having some error in measurement, so automatically volume and surface will have some errors. So here 4/3 pi or 4 pi, they are simply dimensionless constant numbers. So they are not going to influence the error part. So whenever we have that del s by s, I can write it as 2 del r by r. So it is definitely 2% as del r by r is given as 1%. So this is going to be a very simple trick for doing this type of problems, because here surface area is depending upon r as square. So automatically your surface area measurement error will be simply the 2 times of the radius measurement error. So that is 2%. So for volume, you need not to do anything. So del v by v will be 3%, because here the measurement is dependent upon the cube of radius. So in place of error, it will be simply 3 del r by r. As del r by r is 1%, so volumetric measurement error has to be tripled and it will be 3 times of the measurement. So suppose it is given that surface area measurement of a sphere is having 5% error. So this is suppose given as the del s by s percent. The surface area measurement error for a sphere is 5%. So what should be the volume measurement error of this particular sphere? So 5% is the surface area measurement. So what about the radius? If radius error is delta r by r, so surface area is actually twice of that. So delta r by r percent is actually 5 by 2, that is 2.5%. So volumetric measurement is, we know it's 3 delta r by r. So it has to be 3 into 2.5%. So it has to be 7.5%. So these kind of questions are always important for any competitive exam. So for that we need to remember a simple idea that wherever radius, volume, surface area they are measuring like this, 1%, 2%, 3%, that doesn't matter. You have to be checking out through the powers. That surface is depending upon radius, height, or whatever the things, the parameter. So what is the actual power they are having the dependence on? So this is going to be an important role playing for every single parameter. Now the important thing is that from this particular point, suppose it is asked to you that suppose you are measuring the volume of a cylinder and the radius is having 0.5% error and the height is having 3% error. So what should be the error in measuring the volume? Then what to do in this question? We know very well, it's a simple question that volume is actually pi r square h, where pi is a constant. Now the thing is important, that is volume. The del v by v percent will be 2 del r by r plus del h by h. So this will be that simple nature. And so from here it will be 2 into half plus 3%. So finally it is coming as 4% error. So this kind of questions are also important when we study about our NEET questions. Now from here we are going to discuss one of the most important type of questions, that is a kind of word related problem. Suppose it is asked that on a square surface area, if if the force is working, I have to find out the percentage error in measuring the pressure on the area. So suppose the error in measuring the force, is 5%, and the error in measuring the length of the square area is 3%. Then what should be? So this is for the force and this is for the length of the square. So these are the errors for measuring the force on the area and the measuring the length of the surface area. So what should be? The percentage error for measuring the pressure. So del P by P, here we know that P equals, this is to be asked, and we know that pressure equals to force by area, and that is going to be played a very crucial role for this particular section, that is F by L square. So it is del P by P percent will be del F by F plus 2 del L by L. So this much percentage will be playing the vital role. So here it is 5 plus 2 into 3. So it's simply 11% will be the answer for this particular thing. So this kind of questions are always important for us and always important for any competitive exam. We are planning to sit for whatever be its NEET, whatever be its any other competitive exam. Now from here, one thing we are focusing on, that is, suppose a question came like this, that you are given a simple pendulum and to find out the length of the pendulum, there is an error of 3% and there is an error of 2% for measuring the time period of the pendulum. So how can you get the percentage error? How can you get the percentage error for this particular thing, that is acceleration due to gravity? So how can you deal with this problem? That is very, very important, that we know the famous equation that T equals to 2 pi root over L by G. So T square equals to 4 pi square into L by G. So G stands for 4 pi square into L by T square, like this. So from here it is del G by G. 4 pi square is basically a constant, so it is going out. So it is del L by L plus 2 del T by T, like this. So if it is percentage I am looking for, so del G by G, it's del L by L plus 2 del T by T percent. So del L by L is how much here? Here del L by L goes for 3% plus 2 into 2. So finally how much it is coming? So it is 3 plus 4. So finally the measuring G will give you an error of 7%. So 7% is going to be the error in measuring the acceleration due to gravity on this particular type of problem. Suppose it is asked in a question like this, that suppose mass and velocity is given. Suppose mass and velocity is given and its measuremental error is given. So for mass, suppose the error is 4%. For velocity, the error is given 3%. So they have asked you about the percentage error to find out the momentum and about the kinetic energy error. So that is del K by K percent. So these are the questions asked in this particular format. So how we can solve it? We know very well that momentum is often represented by P, that is mv. Kinetic energy is simply half mv square. So we know that del P by P percent will be del M by M plus del V by V percent. So finally how much it is coming? It is del M by M is 4, del V by V is 3. So it is finally 7%. Now from here the kinetic energy, and we know that del K by K percent, the half is not going to play any role. So it is delta M by M plus 2 delta V by V, and it will be the percentage error. So delta M by M is again 4%. So 4 plus 2 into 3 and this much percent you can have. The 10% error it is going to be having. So this is very, very important thing we must have generated from this particular section, and this is very, very important for us also, that to go through this kind of problems wherever we can get from the question paper, from the books you have, from the materials we are providing online. So from anywhere you can practice this kind of questions. There are enough questions that you can practice we have in our resources. So you have to trust Mock Test for You for this. There are plenty questions given in our website and the app. Now the thing is that from here we are going towards the next type of problem which is playing a big important role in different competitive exams, and that is an experimental orientation result. So experimental orientation question, so there can be some questions like you can find out lot of dependent questions from here, and suppose this type of questions you can have that you are going to measure the area of a rectangular slab. So I am giving you a set of information from our rectangular slab. Suppose it is length is given as 10 plus minus 0.2 meter, 10 plus minus 0.2 meter, and the breadth is given as 5 plus minus 0.3 meter. So here a lot of questions are asked. First of all, area of the slab, first question. Next thing is how much error involved to measure the area of the slab. Number 3, proportional error. What is the proportional error in this experiment? And number 4, that is percentage error of this experiment. So these 4 questions are there to find out this particular question. From these particular questions you have to solve these 4 queries. Now here the lengths are given. It is actually that all the original length. Here the length is given for the slab but not the actual length. It is given as the slab's length as well as its error is included within the length. So what it is actually given? It is L plus minus delta L. It is breadth including the error measuring the breadth. So finally this is the thing. So when you are actually going to find out the error, you are not going to find out the A, which is the area which is length into breadth. You are going to find out A plus minus delta A, or in place of error you are going to find out plus minus delta A. In proportional error you are going to find out that plus minus delta A by A, and in the percentage error you are going to find out delta A by A into 100%. So these are the questions you need to solve from this particular type of question. Now if I write down the actual thing that L equals to, that is A equals to L into B, so the area becomes 10 into 5, so it is 50 meters square. It could have been given in centimeter also, no issues. Now the thing is that when it is given in 50 meters square you got. Now if I write the error equation for proportional error, that is delta A by A should be del L by L plus del B by B. So how much it is coming? It is definitely 0.2 by 10 plus 0.3 by 5. So how much it is coming actually? If I multiply this by 2 on the both numerator and denominator, it is 0.02. And how much it is coming? It should be 0.6 by 10, so plus 0.06, so it is coming as 0.08. So this is one answer you got, the proportional error. This one answer you have got from here, the proportional error. And if you got the proportional error, you will definitely get the second one, that is the percentage error. The percentage error you will get, that is del A by A percent. that is 0.08 multiplied by 100%, so it is definitely 8%. So this is the error you get for the percentage error. That is very, very important for us. Again, another thing which is so important for us, that is the error in this experiment, which is very badly needed. That error, you know from here that delta A by A is this. So if delta A by A is this, so delta A will be A into 0.08. So it is 50 into 0.0, shift one decimal point, it is 10 into 0.8, 0.8 becomes 0.8, 0.8 into 5 it becomes 4. So finally it is 4 meters square. So this is actually the error. This is actually the error, which is plus minus 4 meters square, and this is the answer of the question part number 2. And what is the final answer we got? That is very important. This error we got as 50 plus minus 4 meter square. So this is a very, very important expression. This is very, very important expression for us. And we have a very, very important part of this particular topic, that's 50 plus minus 4 meter square. So this is going to play a very important role, that is error analysis. We have the rectangular slab, this kind of question, and not only this kind of question, we need to go through two types of this type of questions to go through the proper view of this question. And here I hope this question is clear to you, such that we can use more than 2-3 questions on the basis of this. So one type of question I need to show to you, and this we will again discuss in other chapters, but this is actually an application of significance of derivative, which is basically motivated from this particular concept in physics, which is the error analysis. And I hope this is clear, and I am going to start afresh, and I am going for a fresh screen once again. So I hope this kind of questions you have liked well, and you have understood well enough to go through the next level of this question. So from here I am taking you to another type of question. Suppose you have seen it very well in previous knowledges when you have done some previous classes topics. So you know this kind of questions very often, that suppose keeping the mass unchanged, keeping the mass constant, if the radius of the earth is increases by 2%, what will be the change in the value of g, acceleration due to gravity? I hope you have done this question. I don't hope it's, I'm sure about it, that you have done this question several times in different for board level preparation and competitive preparation as well as possible. So this kind of question, there is g, we know there was an equation like gm by r square, these two are taken as constant. So if I go for a percentage measurement, so initially it was r, now it is r plus r into 2 by 100. Now for that g has become g dashed, you are taking their ratios. It will be a hectic task for us to go through all this calculation, and end of the day we may be wrong with our calculation in the whole tension and panic. So what we can actually do for this type of questions, when we know that g equals to gm by r square and this part is a constant, we can easily write that del g by g percent, it is actually minus 2 del r by r percent. We know that error equation does not take the minus here. The minus sign is denoting what? Here 2% increase means this minus signs means decrease. We know due to the inversely proportional relation, this minus sign is actually showing you the decrement. When 2% radius increases, g has to decrease by 2 into delta r by r. So that is 2 into 2%, so it is minus 4%. And by error you don't take that minus sign, but you know very well that g is decreasing with the radius increase. So if this minus comes, don't take it that much seriously. It clearly says that if r increases, g decreases. So this type of questions you can also solve on the basis of the concept of error analysis. I hope it is clear to you all. And we are going to another that kind of question that we did just while ago. Suppose in a measurement it is given the voltage or the potential difference is given like V plus minus del V form. It is given like 10 plus minus 0.3 volt, and the resistance R plus minus delta R is actually given as like 5 plus minus 0.1 ohm. So it is asked that what is the current, what is the error in measuring the current, what is the proportional error, and what is the percentage error. So these are the 4 questions asked in this particular problem, and we know very well this is not current asked, it is asked the current along with its error. So we know very well here the current is actually V by R. So it is definitely 10 by 5 and it is surely 2 ampere. So whenever we are going to have the delta I by I, so this delta I by I will be what? It is actually nothing but delta V by V plus delta R by R. So delta V by V is 0.3 by 10 plus 0.1 by 5. If I multiply this 0.1 by 5 by 2, so it will be, you can take it like 0.2 by 10. So finally it is coming as 0.05. So it is 0.05. So delta I is actually I into 0.05. So I is how much it is given? 2. So 2 into 0.05 is 0.1 ampere. So if it is 0.1 ampere, so finally we get the current and delta I by I. So 2 answers we have got. So this is the error, that is plus minus 0.1 ampere. So how much will be the percentage error? So simply it is 0.05 into 100%. So we are getting as 5% error. So 5% is the percentage error. So final result that we are getting from this particular point, that is 2 plus minus 0.1. We are having how much? So 0.05, 2 plus minus 0.1. So this will be the current in this particular point, because if I go for 10% error, so it would have been 0.2. So 5% will be simply half of that. So it should be 0.1% error. And I hope that this kind of questions is not going to trouble you further in any kind of exam, because these questions are so easy, so simple. So actually they are so much important for our different types of exam. And that is why we need to concentrate on this type of problems, like one question, and we will be ending our error and analysis and the dimension with that type of question. Suppose in a parallel combination of 2 resistances, like 2 resistances are given. Suppose R1 is given like 30 plus minus 0.3, and R2 it is given like 60 plus minus 1.2 ohm, and they are connected in parallel. So we have to find out the percentage error for their parallel connection. Now we know their parallel connection is what will be the actual R1 R2 by R1 plus R2. So R1 R2 is 30 into 60 divided by 90, because 30 plus 60 is 90. So it 0 goes up. So it is 180 by 9. So it becomes 20 ohm. So 20 ohm is the actual, but we need to find out the error. So as we know that 1 by R equals to 1 by R1 plus 1 by R2. So if I take the differential here also, it will be delta R by R square equals to delta R by R1 square plus delta R2 by R2 squared. So finally how much it is coming, that is highly important for us, that we need to have this delta R by R actually. So when we think about the percentage error of whole this calculation on delta R we need, so for that here also we need to have the squares because of the differential properties, and delta R by R square, here delta R by R square you can keep it like this. So delta R you got it 0.3 by 30 into 30 you have, plus delta R2 you got 1.60 into 60 you have. You can go for an LCM, and how much you will get? If you go for an LCM, it's 30 into 30. If you go for it, you will get how much? That is 0.3, and it is coming as 10, 100 it is coming. So it is 100 into 30. If you go for it, it is coming as 1.2 by 60. So it is hardly again coming as 50 into 60. So finally you can see here that on the denominator you are getting 3000. On the denominator you are getting 3000. So it is 1 plus 1 finally. So delta R you are getting how much from here? You are getting delta R by R square equals to, so delta R for you is coming as R square by 3000. So R square is how much? R is 20. So it's 20 into 20 by 3000 you are getting. So 0 zeros are going. So 4 by 30. So ultimately 4 by 3 is 1.33. So 10. So it is delta R by R you are getting as 0.133. So final answer what we get for the actual percentage error. If I think about the percentage error, so I have to multiply it by 20. So how much I will get, or the radius I am getting as R plus minus delta R. So that will be how much? Delta R is 0.133. So my answer will be 20 plus minus 0.133 ohm. And if I think about the percentage error in this case, so we got that delta R by R square equals to how much we got? It is 20 there over there. So here you got a very important thing. See, there was a 2 into 20. So there will be a 2 part here. So we must be 0.266. So this will be our most important result of this experiment. So finally it will be coming as 0.266. So delta R by R square what we got? It is 2 by 3000. So 2 by 3000. So what will be delta R by R finally? So if I get delta R by R, so this 1 R will be on this side. So 2 into 20 by 3000. So 0 is gone. So it is 4 by 3 by 100. So 1.33, 0.0133. So if I take the percentage here, again I have to multiply by 100. So percentage error will be surely 1.33%. So this is actually a trick to solve this kind of questions when we will have the inverse ratios in power, and you have to take the differential method where the powers are given in this particular order, that during the differential the denominator is carrying the square, so the ultimate equation will take some new change. So this kind of questions are more than enough for solving any type of previous year and the next year's questions on this particular topic for NEET or any other competitive exams. So children, kindly go through, and whenever you are aspiring for a medical rank in NEET 2021, we have to be that much cautious about what type of questions we are surely be facing in the different types of exam as soon as possible. So whenever we will be completing our mock test and all the chapter wise tests, you will be seeing that how much type of questions we have segregated, we have permuted and combined for this type of questions for your preparations. So I hope this entire part of units and dimensional error is over, and you will be going through these particular things entirely from our app, online study material, question paper and all these things. So end of everything, we are looking for an ultimate enrichment for your knowledge focusing on NEET 2021. So thank you everybody. We are coming back soon with the next classes on kinematics. Stay tuned and go for the apps regularly and get enriched with the different materials. Thank you everybody.